Have you ever seen one of those incredible drone light shows? You know, where hundreds, even thousands of lights are just dancing in the sky in perfect sync? Or maybe you've heard about search and rescue missions using these teams of flying robots. Well, that right there is the power of a swarm. And in this explainer, we're going to break down how these swarms actually work, and more importantly, how they learn to think like a single intelligent unit. Okay, so let's just dive right in. The uses for these things, which are officially called unmanned aerial vehicles, or UAVs, are absolutely exploding. I mean, think about agriculture, where swarms can monitor every single inch of a massive crop field, or environmental surveillance, where they can track animal populations or the spread of a wildfire. They're changing everything from package delivery to providing critical support in military and disaster relief operations. The common thread, the real secret sauce here, is collaboration. And that brings us to the big question, right? It's not like there's one person with 100 joysticks trying to control everything. No way. This is something way more advanced. It's about creating a collective intelligence, a kind of distributed brain where each robot makes its own decisions for the good of the whole group. So how in the world do they pull that off? To really understand the how, we first need to get a solid grip on the what. What exactly makes a group of drones a swarm? Because it's a very specific idea, and it's inspired by things we see every day in nature, like flocks of birds or schools of fish. All right, let's lock in a definition here. The keywords you're seeing are autonomous, local sensing, and collaborate. This is a huge, huge shift from some centrally controlled system. In a swarm, each drone only perceives its immediate surroundings and only talks to its neighbors to make decisions. There's no CEO drone calling all the shots. It's like a democracy of machines. And this image right here, it shows you exactly why that decentralized approach is so incredibly powerful. By working together, the swarm develops these emergent properties, abilities that no single drone could ever have on its own. It is a system that is truly, and I mean truly, greater than the sum of its parts. Let's break down what makes them so powerful. First up, scalability. You can go from 50 drones to 500 without the whole system just falling apart. Then there's robustness, and this is huge. If one drone fails, the others just adapt and keep the mission going. They're also adaptable to whatever the environment throws at them. They're cost-effective. A whole team of simple bots is way cheaper than one complex super robot, and they can do lots of tasks in parallel, which makes them ridiculously efficient. So how do they learn this really complex, coordinated behavior? Well, the magic behind it all is a specific kind of artificial intelligence called machine learning. But you gotta know, not all machine learning is the same. Now, this is where it gets really interesting. You're probably familiar with supervised learning. That's what recognizes faces in your photos after learning from millions of labeled examples. And unsupervised learning is great at finding hidden patterns. But for swarms, the real game changer is reinforcement learning, or RL. This is where the learning happens through pure trial and error, just by interacting with the world around it. So, in the world of reinforcement learning, we call the decision maker the agent. You can think of it as the software brain, not the physical robot itself. And for our swarm, it's pretty simple. Each individual drone is powered by its own learning agent. Now, that agent has to operate somewhere, right? We call that the environment. For a drone, that's the real world. It's the airspace, the wind, any obstacles, and of course, all the other drones flying around it. And the environment is constantly giving feedback based on what the agent does. And that feedback, well, it comes in the form of a reward. And this is maybe the most important piece of the puzzle. The reward is just a signal that tells the agent, hey, that was good, or nope, that was bad. For a swarm, a positive reward might be for keeping the right formation, or avoiding a crash, or getting to a target. The agent's entire goal, its whole reason for being, is to take actions that get it the most reward possible over time. But maximizing that reward isn't as simple as just grabbing the closest piece of positive feedback. Nope. The learning process has some really fascinating rules that allow for complex long-term strategy. And this is where we see the difference between reward and value. A reward is immediate. It's like getting 1 point for moving a step closer to the goal. Value, on the other hand, is all about the future. It's the total reward an agent expects to get from this point all the way to the end. A really smart agent learns to pick actions that lead to high-value situations, even if it means passing up a small, immediate reward. This all leads to a fundamental problem in reinforcement learning, and this quote just nails it. It's the classic challenge of exploration versus exploitation. Do you stick with what you know works and collect those rewards, or do you try something totally new that might, just might, lead to an even bigger payoff? Here is the perfect analogy. Exploitation is going to your favorite restaurant. You know the food's going to be good, it's a sure thing. Exploration is trying that new place that just opened up down the street. It could be awful, or it could become your new favorite. A good learning algorithm has to find just the right balance between those two. Okay, so we've got the theory of reinforcement learning down, but how does this software brain actually connect to the physical drones? You know, their bodies, their sensors, and all that. Let's look at how we get from theory to reality. You have to picture each drone in the swarm as its own little flying computer. It's got sensors like GPS and cameras to see its environment, it's got processors to run that learning algorithm, and it's got communication systems to talk to its neighbors. It's a totally self-contained unit. This table breaks down that whole loop perfectly. So you have the drones themselves, and their sensors gather all the data, that's the sensing part. The communication system lets them share that data with each other. Then the algorithms, that's our reinforcement learning agent, do the thinking, processing all that information to decide what to do next. And finally, the drone acts on that decision. It's a continuous, never-ending loop. So here's the bottom line, the most crucial point. Reinforcement learning isn't one big central computer controlling everything like a puppet master. No, it's a policy, a set of rules that gets loaded onto every single drone. This lets each unit learn its own specific role within the group, and that's what creates that beautiful decentralized coordination that we see in the sky. With a technology this powerful, the possibilities feel absolutely endless. But what does the future actually hold? And what are the hurdles still standing in the way of this stuff becoming commonplace? This slide just captures the two sides of the coin perfectly. On the left, you see the immense potential, all the amazing things we've talked about that promise more efficiency, more robustness, and just brand new applications in pretty much every industry you can think of. But on the right, you see a long list of very real, very difficult challenges, everything from communication to legal stuff that researchers are working around the clock to solve. And these are the big ones. Seriously, how do you keep thousands of drones communicating without jamming the signal? How do you deal with limited battery life? How can you 100% guarantee they won't collide with each other in a chaotic, unpredictable environment? And maybe the trickiest one of all, what are the laws and regulations going to be for deploying autonomous swarms in our public spaces? These are not easy questions to answer. Which leaves us with a final, really powerful thought. We've built systems that can learn complex, cooperative behaviors all on their own, through trial and error, pretty much like we do. The technology is here. So the real question now is a very human one. What missions are we going to give them, and what values are we going to program into their rewards? The future is definitely swarming, and it's up to us to guide it.